Welcome back to another Daishinfinity video. In this video, we're going to talk about or prove the derivative of the cotangent function, which is just the inverse of the tangent. So we are just going to prove that the derivative of the cotangent function, which is a normal trigonometric function, is that this function is equal to the negative of the cosecant squared x. So let's try and prove this using the limit definition of the function. Now, if we talk about the limit definition, the derivative of any function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, since we have this, we just plug in the cotangent inside of this limit. So we'll just have the limit as h approaches 0 of cotangent x plus h minus cotangent x all over h. Now what we can see is that cotangent has its own identity. So cotangent of x is equal to 1 over tangent of x, which is just the same thing as 1 over sine over cosine. So cosine x over sine x. So we just use cosine x and sine x in this limit so that we can simplify the limit a bit further. So we will just have the limit as h approaches 0 of cosine x plus h over sine x plus h, and the whole thing minus cosine x over sine x, and the whole thing over h again. Now what we're going to do is we're going to cross multiply sine with cosine x plus h and sine x plus h with cosine x, so that we can put them together in one whole fraction. So we'll just have cosine x plus h times sine x minus cosine x sine x plus h, and this whole thing over h times the product of those two denominators. Now what I want you to see is this numerator. This numerator reminds us of something. Well, if we see the numerator, let me write it down again. It's cosine of x plus h sine x minus cosine of x sine x plus h. If we let x plus h equal to a and x equal to b, then the expression will become something like this: cosine of a sine b minus cosine b sine a. This reminds me of the subtraction of two variables inside the sine input. So it is just equal to, I'm just not going to explain why because there's a proof about it in my videos. So it's just the sine of b minus a. And since we have x plus h and h, b was indeed x and a was x plus h. So we'll have the sine of x minus x plus h in brackets. So we'll just distribute it. So we'll just have x minus h. The x's will cancel, which leads us to having the sine of minus h. And since sine is an odd function, we can put the minus sign out of the sine input. So we'll just have negative sine of h. So we will now put the negative sine of h into our new limit. It is actually the same limit, but it's just a different type of mathematical expression. So it's minus sine of h over h. So the denominator hasn't changed at all. So I'm just going to write all of them down and see something very, very nice. So we have sine h over here, and we know the limit as h approaches 0 of sine h over h. So since we have the limit property of multiplication, we're just going to put the negative sign out, write the limit for sine h over h, then multiply the limit again as h approaches 0 of 1 over sine x plus h times sine x. Now, as you can see, this limit approaches 1. The proof is going to be in another video, so the negative sign will stay here. and the h, if we plug in 0 over here, will be 0. So I will have this can vanish because in the product 1 is just nothing, so negative 1 over sine squared x. And what is 1 over sine x? 1 over sine x is the same thing as cosecant x, so this is just a negative of the cosecant squared x. So I hope you like this video. Please like and subscribe, follow for more, and I'll see you in the next Daishinfinity video. See ya.